Hello, can you hear me at the back? Cool. I'm Miles. I'm an engineer on the infrastructure team at Monzo. And today I'm going to be talking about how Kubernetes has helped us build an amazing kind of modern bank backend. Kubernetes is a pretty kind of core part of the Monzo tech stack. And it's helped us kind of build a product that's helping over 1.8 million people manage their money better. So if you haven't heard of Monzo, we're responsible for these kind of very brightly coloured cards. You might have seen, especially around London. We actually call this colour hot coral and not hot pink, as has been reported in the press. Just want to clear that up. But it also comes with this kind of great banking app, which comes with a lot of features to help you manage your money, help you budget, help you pay your friends, and kind of split bills for or restaurant meals. Get access to loans and credit, and 24-hour support as well. And Monzo's been using Kubernetes for nearly kind of 3 years, and at the time when we decided to adopt it, it was relatively new and unknown technology. And this is always a potentially kind of risky decision for a kind of young startup. And there's this blog post our head of engineering, Ollie, did, and an excellent KubeCon talk to follow up, which explains why we decided to give Kubernetes a go. Quite a lot has changed in that time. So at this time, we were still on kind of prepaid cards. We'd issued about 70,000 of them. We had a handful of engineers. As I said, we've got now 1.8 million customers with full kind of current accounts, and we've got over 120 engineers. So this talk is kind of reflecting on the points in this blog post and on those decisions and kind of what we've learned about running Kubernetes. But first, let's take a step back and consider what I mean by a kind of modern bank backend. Just a photo of a IBM mainframe. This would have been considered state-of-the-art kind of banking technology, maybe a number of decades ago. But these machines, or at least their kind of modern equivalents, still power a lot of major banks. And they're kind of designed for a different era of banking. There's a lot of overnight batch processing, daily tape backups. And over the years, banks have just been kind of adding more and more kind of stuff onto these. So they've become these huge, scary kind of legacy systems that are very difficult and risky to change, as TSB found out last year. And this has meant that the kind of technology and customer experience has fallen behind in recent years. And obviously, it's very easy for me to come up in here and say that, because at Monzo, we've had the luxury of kind of being able to start from scratch and use modern technologies and tools from the very beginning. So some of the things that are really important to us. First of all, this system needs to be extensible. It's a bit of a cliche, but the only constant is change, really. We are constantly kind of building on this system, adding kind of product features. I've just grabbed a kind of small list of stuff from our website that we've currently got in flight. And this is just kind of an average kind of day-to-day kind of stuff at Monzo. We're constantly looking at improving the product. So this system needs to be able to handle like a vast amount of change without too much kind of re-architecture, and without it kind of descending into this huge kind of like spaghetti mess. We want the system to be scalable as well. We're signing up a lot of new people, and we don't, like I said, we don't really want to have to go and kind of do this big re-architecture at any point. And the biggest test we've had of this so far was the crowdfunding round we did in last November, where basically we told all of our customers that they could log into the app from 10 a.m. and try and to get a chance to invest in Monzo. And that's what the graph on the left shows, is the kind of uptick in traffic. Of course, one of the most important things is about being a bank is that people trust us with their money, and it's our job to kind of keep that safe. And this obviously means that our system needs to be really easy to secure and keep secure. Similarly, we also want our system to not kind of rely on these sort of batch processors and be able to process things in real time. So if you're anything like me, you can get told off when you're spending too much money on your lunch with a notification. And to kind of link the previous two together, we want to have kind of real-time fraud detection and monitoring. This is a great story from a couple of months ago about our systems blocking a transaction in real time that wasn't made by the cardholder. And we then sent a push notification to the account holder within a few seconds to tell them exactly what had happened. And we also want our systems to be up and available all the time, especially important for us because we're an app-based bank. So if our app is down, there's not much you can do. We think people should be able to access their money kind of 24/7. We have a lot of customers who travel, who might be in different time zones. And this is an example from this last weekend, actually. Obviously, all the clocks went forward, and a lot of major banks had, because they're based on these kind of mainframe systems, they need maintenance windows to be able to wind the clocks back. And we really want to kind of avoid this and avoid kind of having to book maintenance windows where people can't actually use their account. And reliability comes into this too. We'd rather avoid having unplanned outages as well. And to kind of tie this together, we want to do all this without kind of breaking the bank, so to speak. Whilst we have got a significant amount of investment, which we're very fortunate to have, we need to use that money smartly, or we're not going to get more investment. So to kind of set the scene for what our environment looks like, the environment was set up to solve these problems. The natural kind of architecture that lends itself quite nicely to a lot of the things I mentioned is microservices. And we've kind of taken this almost to the extreme. We've got over 1,000 microservices, all doing very, very kind of small individual tasks. And this is working great for us because we can scale each part of the system independently. So, for example, if our kind of banking ledger starts becoming a bottleneck, we can just sort of scale that bit without affecting the rest of the system. This is also scaled really well with the number of engineers as well. We can have many, many teams working on completely separate parts of the code base and deploying these things independently. And we can also deploy multiple instances of each service to make them highly available. And that's just part of our infrastructure. So the majority of it, so we run our microservices in Kubernetes, alongside a couple of things like Kafka and Elasticsearch, used for queuing and some data storage, along with Prometheus to kind of monitor everything. We're running Envoy as a service mesh to kind of help us reliably kind of communicate between services with retries. There's a few things we're still running outside of Kubernetes, such as Cassandra, our main database, and also NSQ, which is another queuing technology we use. But over here on the left, you might be kind of surprised to hear we actually have a couple of small data center presences. And these are required to connect to payment schemes like MasterCard and a fast payments scheme for kind of bank transfers. Because these payment schemes have been designed in kind of like a few decades ago and don't really have any way of connecting directly into the cloud. They essentially just kind of give us a cable and go, plug that into the system. So this is our kind of way of connecting between that and our infrastructure. And we do very kind of little logic in the data centers. As a principle, we try and keep as much processing and business logic in the Kubernetes cluster. It's much easier to update. And if you look back at the blog post I mentioned earlier and the KubeCon talk, a lot of these fundamental components have actually changed very little, which I think shows like how well it's been working so far. So, kind of take a step back a bit. How does Kubernetes help us achieve this? So, first of all, Kubernetes is full of these really powerful and simple primitives. And this is probably one of the most basic things about Kubernetes is we can specify that a number of copies of the service should be running, and Kubernetes just goes and takes care of those and keeps them running. And if we lose a node because of hardware failure or some kind of error, Kubernetes is just going to start a new copy of that service. And especially with over 1,000 services, this is definitely not something we want to be managing ourselves or doing manually. At a kind of layer up, Kubernetes can also handle deployments for us really easily. So here we can just specify the version of an image, and we can run Kubernetes tooling to change the version of that image, and Kubernetes will go away and handle the automatic safe rolling update, which keeps the services kind of always available. It means we don't need these maintenance windows. And this has actually worked so well for us. It was the primary kind of method of deployment at Monzo up until kind of mid last year, because we just didn't really even need anything much more complex than that. And then when we did need to kind of build something more complex, we were able to use the Kubernetes API. So this is the same thing written in kind of Golang client, which we've written in our own kind of service to handle deployments for us. And this goes for absolutely anything in Kubernetes is accessible via the API, and we can build some really kind of powerful stuff on top of it. So Kubernetes also really helps us with security. As I mentioned earlier, we have these data center presences to connect to MasterCard and the fast payment scheme. And it goes without saying, really, these connections are very, very sensitive. It'd be really bad news if someone compromised them. So let's say we want to make sure that only kind of certain services can access the data centers. So for example, the example I've got here, service.mastercard, should be able to have access, but service.ledger doesn't need to access the data centers, so it doesn't. And Kubernetes has another kind of really nice primitive for this, which is network policy, which allows us to do these really kind of fine-grained like firewall rules, essentially, to specify that only like service.mastercard should access the data centers. And continuing on kind of with security, and this isn't specific to Kubernetes itself, but Kubernetes helps us by kind of running our services in containers. And we base our service builds off a special kind of Scratch Docker container that contains absolutely nothing, because most of our services are written in Go. We can just build a kind of fat binary, deploy it in a Scratch container. And there's no kind of base operating system stuff. There's no, the only kind of attack vector really is via our code within the container. And if someone did manage to compromise the container, they haven't got access to kind of shell executables or anything like that. I think one of the most important things about Kubernetes is, of course, it's open source and the community. And at the very least, this means that if we have kind of issues, we can actually dig into the code base ourselves and try and fix these problems and contribute these back to the community. The community is pretty incredible as well. There's a huge amount of support from kind of big tech companies and individual contributors. And we have a lot of confidence in the quality of kind of Kubernetes releases. And it's just great being able to go to conferences like this and meetups and talk to people about kind of common problems that we're having and sharing tips. On to some of the lessons we've learned from running Kubernetes for 3 years. So it's certainly extensible, as I said. We have over 1,000 microservices. We're able to deploy these regularly on a daily basis down to individual teams when they want to deploy something, and we're able to scale these individually. And I think it's a pretty bold decision to go for building a kind of microservice architecture from the very beginning. I think it adds a lot of kind of overhead, takes time away from kind of building actual sort of producty things. But I think it's really paid off. We haven't need to majorly kind of re-architecture. And like I said, we're still able to maintain this velocity. Something else we've learned is that it's very important for the system to be observable. And what I mean by this is that we're able to kind of infer and dig into the behavior of the system using tools like logging, distributed tracing, and metrics. And I've got a graph here from one of our most important dashboards. And this shows our kind of MasterCard processing system. So when someone goes into a shop and taps their Monzo card to pay for something, the card terminal will send a request via the MasterCard network. And the MasterCard network will send that to us and basically go, should this payment be allowed? And we have a bunch of services internally, like 40 or 50 involved on this kind of critical path, which have to do a wide range of things. So very basic things like check the card details are correct, match the card details to someone's account, check that person's balance to make sure they've actually got enough money to pay for something, run various fraud checks, and finally, most importantly, kind of inserting a transaction onto the banking ledger to record the movement of money. And this graph shows the latency of like the call path through 50 services, and it's quite important because if the latency starts to creep up, then eventually you'll get to a point where Mastercard will start declining transactions, and that's not great. So if that happens, we need to very quickly be able to work out which of these 50 services might be the culprit, and this is why observability is very important. So everything I've said so far is a pretty rosy picture of Kubernetes, and it is great. We really love it. It's helped us a lot. But as with any kind of complex system with lots of automation, things have the potential to go really wrong. And this is a really interesting GitHub repository curated by Henning Jacobs of Zalando. It's got a collection of Kubernetes failure stories. Definitely go and check it out. It's really, really interesting. Unfortunately, Monzo is on that list with a kind of post-mortem of a bad outage we had back in October 2017. And it's a story of a classic kind of cascading failure and perfect storms of bad interactions between components. And I don't have time to kind of tell the full story of this. There's a great talk, KubeCon last year, called Anatomy of a Production Outage, where a head of engineering talks about this in detail. But essentially, we took the entire platform down for an hour, where no one could use their app, card payments were declining, no one could obviously transfer money. And it was kind of interaction between a etcd upgrade, which is the database that backs Kubernetes, and a bug in Linkerd, which we were using for our service mesh at the time, and a bug in the Kubernetes etcd client, all kind of like interacting with each other. And we essentially tried to restart Linkerd to fix the problem, but none of the Linkerd instances came back up cleanly, and essentially we took down our service mesh. And I don't think this is kind of inherent to Kubernetes itself. I think Kubernetes makes it much easier to build up these complex systems, and it makes the automation of this makes the potential for complex and non-deterministic interactions between components more likely. And I don't kind of say this to kind of scare anyone off using Kubernetes, because it is a great tool. But I think it's important to be aware that things can go wrong. Another kind of early decision we made was to do Kubernetes the hard way and roll it ourselves. And what I mean by this, if you're perhaps not familiar with Kelsey Hightower's excellent tutorial, is that we set up our clusters ourselves, and we generate certificates and install the components and do all the configuration. And to be fair, I think probably at the time, 3 years ago or so, fully managed services were really in their infancy, and the kind of managed automated tooling like COPS or kubeadmin were pretty much non-existent. So this was probably our only option. And I suspect if we were going to start again from scratch now, we would probably want to consider like looking at the automated tooling, because it has gotten a lot better recently. But I think one of the really great benefits we've got from doing Kubernetes the hard way is that we have a pretty deep understanding of how our stack works and how Kubernetes works and how to operate it. And this has proved really valuable, especially when fixing or investigating outages. One example I can think of from last year, a not particularly kind of bad problem, but we found when we were deploying certain services, there'd be a big latency spike. And it wasn't kind of like really, really serious in that we had to drop everything and fix it straight away, but it was just annoying enough people started kind of getting a little bit scared of deploying the service. And it turned out, so we had a service which integrates with Linkerd to give Linkerd information about where to proxy requests. And that service was basically watching the Kubernetes endpoint API. And the Kubernetes endpoint API basically maps between the name of a service and a set of pod IPs. And what we found was this API was actually being really slow to update. So there's a controller within the Kubernetes control plane, which is responsible for watching changes to pod IPs and updating these kind of endpoint objects. But there's a flag on the controller manager, which is kind of like a self-rate limit for the Kubernetes API. And it will basically, it was set too low, and I think it was set to the default, and the controller manager was rate limiting its own requests to the API and not updating any kind of endpoints for like 5 to 10 seconds, which was enough to make it really slow for Linkerd to update its own internal view of where to proxy requests, which was enough to then start sending requests to the wrong IPs and causing these latency spikes. And we were able to really kind of dig into that and fix that ourselves, because I think we had, because we'd done Kubernetes the hard way. And I think a piece of advice I'd give if you're someone who especially works with kind of managed or automated Kubernetes, is to just give this a go yourself as a kind of learning exercise, just to get a good idea of how Kubernetes works. At the very least, hopefully you get an appreciation for how much you're paying for GKE or whatever. So that's pretty much it. Just to kind of sum up, Kubernetes really helped, I think, forms the kind of core part of our platform. And I think we really kind of indicated our early decision to go with it. But it's important to make sure it's observable. When Kubernetes goes wrong, it can go really wrong. But running Kubernetes the hard way has really helped us understand how to fix it. Okay, thank you. Wow, loads of time for questions. Or no questions?
You mentioned earlier on the old mainframes that banks will started to use. They obviously use them because they've been there for a very long time and they've got a lot of stability over multiple decades of use. How do you see this progressing in the next 10 or 20 years from your point of view, assuming that Kubernetes is going to come and go or migrate to something else?
So the question was, the mainframes that I mentioned earlier have been in use for several decades and a pretty much proven stability, right? Was it? And where do we see kind of Kubernetes in maybe 10, 20 years? I think the key kind of comes down to the extensibility. Kubernetes is designed for change. I'd argue that those kind of mainframes might be quite stable, but they're also quite difficult to change. And yeah, it makes it very difficult for those banks to kind of innovate. So yeah, I think because Kubernetes is designed to accommodate this, I think it looks like it'll be quite strong in 10, 20 years.
Do you have any plans for how you might progress in the next 5 years, say, or is that purely depending on what the technology does?
I think that depends a lot on the technology, and for us, I think it's about kind of planning ahead for the next year or so. I think 5 years is difficult for us to work out exactly where we'll be. We're not. Well spotted. So this changed, I think, a few months ago. So we kind of got to the stage with Linkerd. So Linkerd is a kind of a JVM application. So it was starting to use a lot more kind of CPU and memory than we were really quite comfortable with, to the point where we were giving it 2 cores on every kind of Kubernetes worker of an 8-core worker. So we're spending a huge amount of money on it, really. And we did look at, so this was Linkerd 1. So we did look at Linkerd 2, which I believe is written in Rust and has a lot more performance optimizations, much more efficient. But we didn't really feel it was kind of mature enough. So that's why we went with Envoy instead, which seems to have been like quite widely adopted.
And when it crashed, was it the control plane or the data plane?
Sorry?
You said that Linkerd went down and you couldn't get back up. Was it the control plane or the data plane?
The actual kind of like the data plane, the Linkerd kind of daemons themselves, yeah.
How many production Kubernetes clusters are you running?
Good question. So we have one big one, and this is a quite interesting debate we've sort of had internally, and I think is going on in the community as well about whether like putting all your eggs in one basket and having one bigger cluster versus kind of breaking off smaller clusters. And I think it's a set of trade-offs. So one thing you get with having lots of smaller clusters is like a much reduced blast radius. So this particular outage actually would have been a lot less severe if it only affected a part of the system. But I think what you're trading off is a kind of added complexity and overhead of having to manage these multiple clusters. And particularly, I think we're probably getting to about the point now where the tooling on top of like managing multiple clusters is getting much better. So maybe that shifts the kind of the balance a bit. But for us, we found it much easier so far just to kind of run one cluster.
How do you do disaster recovery with one cluster?
Taken.
How do you do disaster recovery with one cluster?
Disaster recovery. So I'm not sure how might it be different for one cluster versus several clusters.
Like failover. How often do you do failover testing and this kind of things?
I don't think it really kind of makes that much of a difference. I think it's probably a bit of added time for like the instances to spin back up. But I think it's still quite complex to like orchestrate kind of failover between different clusters.
Being in a heavily regulated industry, have you had any major security considerations or had to make any changes to your platform to sort of, or any changes to make it more secure and fit in with those regulations?
Absolutely, and this has changed a lot actually. So I've been at Monzo for about 10 months, and this has changed a lot over the time I've been there. And I think we've gotten like big enough now that the regulators have really started kind of taking us seriously, and we've been like working very closely with them. So yeah, they've been very good to us as we kind of grew once we got our banking license. What am I trying to say? Yeah, I guess there's a lot of stuff we've had to go back and kind of rethink, particularly security-wise.
Teams managing the infrastructure like Envoy and all the system components is the same team that manages the application, or it's separate? Some teams manage all the components under the application.
Good question. So I think this is another kind of really interesting debate about how much you kind of empower teams to take responsibility for their own infrastructure. But we've found what works really well. So I'm on the infrastructure team, and we found that kind of us kind of looking after the bottom layers and the platform and the kind of all the Kubernetes and Envoy bits, and making that sort of available as a very like well-defined interface for the application teams to work with has worked really well. We still try to kind of share knowledge about what happens in the kind of deeper layers of the stack, because if you're an application developer, you've got much more kind of context on how your service actually kind of works. Cool. I think that's it. Thank you very much.